A life without transistors. Can you even imagine that? Well, I can't. Because transistors are literally everywhere, like inside your television, inside your computer, inside your radio, your laptop, your phone, just everywhere. But first, let's talk about what is a transistor. So this little guy here is a transistor, and it has only one job, letting the current pass or block the current. So we can say it's like a very small switch. And as you can see here, it has only 3 different legs. Each leg has its own name and function. We have the base, the emitter, and the collector. We have 2 big different types of transistors. On one side the NPN, and on the other side the PNP. But don't worry, the name of the legs will be the same for both types. And of course, for both types we have a different symbol. So first let's take a closer look to the difference between those 2 symbols. So we have 2 different types of transistors, the NPN and the PNP. Our little guy here from a little moments ago belongs to the category of the NPN. The symbol for NPN looks like this. And for the PNP it's almost the same, but the arrow is reversed. So it has to be pointing inside. How does this transistor work? I will first draw a little circuit. So in fact we can say that the NPN transistor acts like a current multiplier. And the value of the multiply factor, we can write it as HFE. And most of all it's between 200 and 800 times. What does this mean? So we have here a battery with a positive side here, negative side here, and it's connected to a switch. We can first see this little circuit here, and then we will analyze the bigger one. So if we press our switch, so it will be closed, the current is able to flow through the switch, through the resistor, and inside the base. And to complete the circuit, the current will flow through the emitter back to the battery. The resistor can have a value of 10 kilo ohms, for example. If there is a current flowing from base to emitter, then the transistor is turned on. So it means if the transistor is turned on, the collector and emitter are connected to each other inside. So they can pass a current from collector to emitter. If this is possible, the current of the battery will not only flow through the base, but will also flow in this direction through the LED, through the resistor. For example, it has 250 ohms, just an example. And then the current will go from collector to emitter. So this current here, I will call it base current. This is the emitter current, and this is the collector current. The multiply factor means if we have a base current of, let's say, 1 milliamps, it's possible for the transistor to let the current flow of 200 to 800 milliamps. But the 800 are just for very big transistors. I think this one has an HFIE of 200 or 250 something. So if we think logically, the current of the emitter equals to the current of the base plus the current of the collector, because this and this, if we add those up, we become the current of the emitter. If we want to turn off the transistor, we can simply turn off the switch, so the current through the base and the emitter will be 0. The connection between the collector and emitter will not exist anymore, so the current can't flow through, so the LED will be turned off. It's a little bit of a different story here with the PNP. I will first draw the circuit again. So this is the similar circuit as here, but a little bit different. Again, we have here the base, the emitter, and the collector. But now the current has to flow from emitter to base. It has always to follow the direction of this little arrow here, just like we had in the NPN. The current flows in the direction of the arrow, and here again in the direction of the arrow. If there is current flowing, the transistor will be turned on again. And how can we let current flow? By pressing this switch. Again, the base can have a current of 10 kilo ohms, and this resistor of 250 again. Again, we have the current of the emitter. We have here the current of the collector, and here we have the current of the base. The current of the emitter is again the same as the same formula for the NPN, because the total current has to pass here, a little bit goes to the base, and the rest goes to the collector. So we can say that the current of the emitter is like equal to the current of the base plus the current of the collector. And again, the same story happens. If you press the switch, the current can flow in this little circuit here. Current is flowing from emitter to base. The transistor is turned on. There is a connection between emitter and collector, so the current can not only go in this direction but also in this direction. So the LED will be turned on, and that's how transistors work as switches.